Is this the kind of thing that
I was like, are you kidding me? And he was like, which one? Which one was the one the one that Julie like decided? I was like,
All right, kids. Get out your periodic table for me, please. This top part. Now then, if you're not learning this stuff as we go along, I'm going to leave you behind. And then you're really going to struggle. Everybody understand? Yes, ma'am. So my expectation of you is to learn it. And if you're not learning it, I haven't seen you in tutorials. All right. Is that focused or is it me?
I can leave it.
But I mean, it just seems what?
It seems a little
grainy.
Grainy is what it is. Yeah.
too much.
I don't know why. Oh, thank you. That's today's stuff. Yeah. Okay. Okay, everybody go find sodium. How many protons? Everybody write the symbol down. We'll just do a little practice on that also. How many protons does Na have? 11. Okay. Number of electrons? 11. Scoot it over to the left like I did because we're going to do something else with it in just a minute. Well, or just, you'll have enough room. Now then, number of valence electrons for group 1. And if you can't answer that question, you're already way behind the curve. Okay, what is its oxidation number is the same thing as this.
I can't see that.
Ionic charge. Say it again.
+1.
Plus 1. Okay, so how does it get to be a plus 1? It has 11 electrons for the neutral atom. And then when it loses its one valence electron, it ends up with how many? 10. 11 minus 1 is 10. Okay? Oh my gosh, sinus drainage kills me. Chlorine. What's the symbol? How many protons? Okay. How many electrons? Leave that blank for just a minute. How many valence electrons? 7. How many more does it want? Remember, everybody wants how many in their outer shell? 8. So its ionic charge is what? -1 because it gains or loses? Gains. So 17 goes to what?
18.
Very good. Symbol for beryllium? Okay. Number of protons?
4.
Okay. Number of electrons?
4.
Okay. We'll finish that off in a minute. Number of valence electrons?
2.
Okay. When it loses those 2, its ionic or oxidation number is what? Plus 2. Okay. So what happens here? Loses 2. So it goes to what? 2. Okay. All right. Leaving it with the helium configuration. Fluorine. What's its symbol? Okay. Protons and electrons. Fluorine, baby. Not chlorine. Fluorine. Go up one more. 9. Okay. So this one is 9. but it behaves just like chlorine. Okay. Is it going to, number of valence electrons is what? 7. What's its charge? -1. So it goes from 9 to what? Okay. All right, lithium. And a 3. And a 3. Okay. Lithium's group 1. It behaves just like sodium. What is it? Number of valence electrons? Ionic charge? Okay, so it goes from 3 to what? Oxygen is O. Element number 8 has 8 protons, 8 electrons. Lives in group what? So it has how many valence electrons? How many is it going to gain?
2.
So the charge on group 6 is a -2. Okay, so 8 goes to what?
10.
Who is 10?
Neon.
Neon.
Noble gas.
Mm-hmm. Who's 18? See these numbers?
Yes,
Every one of them are noble gases. Who's 2? Interesting. Okay. Phosphorus is what? Okay. Number of protons.
15.
Okay. That means we've got 15 electrons on the neutral atom. Phosphorus lives in what group, kids?
5.
So it has 5 valence electrons.
-3.
-3 because it's going to gain 3. 5 and 3 make 8. So what does this go to?
18.
Who's the noble gas at the end of the row? There you go. All right. Anybody have questions on the top table? Okay. Here we go. What is the Lewis dot structure for potassium? K. How many?
5.
How many valence electrons does K have?
1.
So 1 dot. It's in group 1.
I was looking at phosphorus.
Okay, that's all right. I screw up all the time.
Fluorine.
All right. Who are we bonding with?
Fluorine.
Okay. So put your F over here. What group does F live in?
7.
So how many dots does it get?
7.
Okay. All metals do what? Lose or gain? Lose. How many is potassium going to lose?
1.
Loses its 1 valence electron. Okay? Now, do you see a spot where that's going to go on F?
Yes.
As it gains that 1? Boom. Right there. Okay? So fluorine gains
1.
exactly. All right. Now, so let's look at what we did yesterday. K carries an ionic charge of plus what? F, a -1. Okay? So, what is the formula? Can you see it's a 1-to-1 ratio because both numbers are the same, just opposite in charge? So, what's its formula? KF. Okay? What's its name? Now, fluoride, most all of us want to misspell it, but it's U before the O. Okay? Now then, when you see K in their Ionic, you will see it also written with brackets around it with a plus, just for the, when we start writing covalent Lewis structures, this is going to make more sense. F, when you see F with its Lewis structures, when they have lost or gained, this is the way that you write the Lewis structure after it has gained more than it's supposed to have. This is telling you that it's supposed to have. This is telling you it has one less electron than it's supposed to have. These are just symbols. Does everybody understand? And it has nothing to do with what we do here. Okay? All right. Let's look at magnesium. Symbol?
G.
How many valence electrons? Okay, who are we bonding with? How many valence? Now, everybody go up to the top because you're going to need more room. How many does I have?
7.
Okay. Only one I takes care of how many? One. Uh-oh. Do we need another I? Yes, we do. Magnesium has to bond, when it bonds with iodine, how many I's does it take?
2.
2. Because magnesium is a what? Plus 2. Iodine is only a minus what?
1.
Do you see that when it's a 1-to-1 ratio, it will always just take one of the metals and one of the nonmetals? We're not in a 1-to-1 ratio here. Now let's look at what the crisscross does and then look at your picture. How many magnesiums?
2.
Look what I just did.
1. 3.
Oh my gosh.
3.
That's a 1.
That's 1.
We're doing crisscross applesauce. What's this?
2.
A 2. Okay. Can you see over here 1 Mg and 2 I's?
Yes.
Because in order for the charge to go to 0, it takes 2 I's to do that. Yes?
Yeah.
Okay. All right. So my formula is what?
MgI2.
MgI2. What's its name?
Magnesium iodide.
Correct. Okay, so I'm going to write my symbol, put my little brackets around it, and what number am I going to put outside? Put your positives and negatives. Plus what? How many did magnesium lose?
Or do we put MG?
2.
Oh, my bad. Thank you. Mg, the correct symbol. Plus 2. Okay?
Shorten the symbol.
And we're only going to do one I. How many dots does each I have now?
8.
8. So it's a minus 1. But we have how many of them? 2. Each I is a minus 1. Questions? Are you relating the pictures now to your formulas?
Yes.
Okay. Symbol for sodium. Group 1, how many valence?
1.
Oxygen, how many valence? And when I do bonding like this, I always try to leave my opens so they kind of meet in the middle. Does that make sense?
So this time you need 2 sodium.
There you go. Can you tell? Because this one only has one to give. Okay. So, absolutely, I have to have 2 sodiums because I'm still lacking right here. Okay? So, this sodium is going to come and bond right there. Okay? Now then, so we know from yesterday, Na is a what? Plus what? Oxygen. Y'all better start memorizing those group charges. Okay. Crisscross applesauce. So it's telling you I need 2 NAs and 1 what? Okay, and remember we never write ones. So what's my formula?
Na2O.
Okay? Na2, 1O. What's its name?
Sodium oxide.
Okay, so I have 2 NAs that are a plus 1. And I have 1O at a minus 2. And it gets how many dots? 8. Questions? Is it making sense to you? Everybody done? What, honey?
I don't understand why we're doing those bracket things.
It's going to really come into play later. Because but not really in ionic bonding. It's going to come into play in covalent bonding. We're kind of not there yet. But I'm kind of getting you used to seeing this. Okay? All right. Sodium again. Na with 1. Chlorine. Oh, so what is this? 1-to-1 ratio. Sodium gives up its electron to chlorine. Okay, my bad. All right, so we've got Na at a plus 1. Where did I get that number?
Yeah.
Because sodium does what or what? It does what with its electron?
It loses, so it has a positive charge.
Which always leaves a positive charge. Okay, and chlorine is what?
Negative 1.
Why?
Because
See, they're all in
it gains
C.
electrons.
Okay, crisscross applesauce, 1, 1. We don't write ones. What's the formula?
NaCl.
Sodium chloride. Okay, to represent their ionic state of gain and loss, it's Na with a plus out on the side, and Cl with 8 electrons instead of 7, hence the minus 1 out here. And you can put ones. Sometimes I'll write the ones and sometimes I won't. But most of the time, when you see stuff, you'll see it with just a plus or a minus indicating. All right, group 2 what? Calcium is a group 2 what?
Metal?
Metal. Remember, ionic compounds are metals plus nonmetals. That was in your notes yesterday. I had you star it. And if you look at every one of these, they're metals hooked to nonmetals. Ca is a group 2 metal. How many valence electrons? 2. Chlorine is a group 7 nonmetal. How many valence? Uh-oh.
We need 2.
We need 2. I left off a dot. Okay, so I got to do another one. I didn't leave myself enough room. Bam. Okay. Now every chlorine should have 8. Yes?
Yes.
And calcium has lost its 2 valence electrons. Okay, so I've got a Ca and a +2 and a Cl with a -1. Crisscross. 1, 2. The correct formula is what? Okay, what's its name? Okay, so Ca bracket +2, and we have 2 chlorines with 8 electrons. At a -1. Okay, last one. Where's Al live? Group 3. So how many valence electrons? Chlorine. What can you see just from looking at your diagram?
You're gonna need
3 chlorines. Okay, so 1, 2, 3. Yes? All right, so we've got Al, and we've got Cl, one with a 3+, one with a -1. Okay, crisscross. Al, Cl3. Okay. Aluminum. Okay, so we've got Al in brackets, indicating that it's in its ionic state and the charge. And we have how many chlorines?
3.
That look like this. With how many?
8.
8. And a -1. All right, so can you relate now your formula writing to the Lewis dot structures?
Yes.
Okay. I have another paper that I'm going to work with you on to finish off this session. Pass those back and lay. You're not going to use them all, there's just one. I'm just not going to take time to count them out. Stick them on an empty desk around you. This is, you can kind of play with this some. I'm going to show you how to do it. I'm not really assigning it. I'd like to assign half of it maybe, and the other half tomorrow.
Like odds, day, and even
I always do 1 through 20.
Yeah, just like do 1 through 21.
On like section 1, do 1 through 21.
Well, I want to kind of hit it because it's a lot to do. Well, I'll think about it as we go through. Okay, if you write large, I can't really help you because there's not a lot of space, is there? All right. What is the Roman numeral telling you about lead? It's charge. Okay. So I'm going to put, now you can do it above or you can do it below. I'm going to put Pb with a +2. Sulfur is S. It's in group 6 under oxygen. What's its charge?
-2.
Is that a 1-to-1 ratio? Can y'all see that?
Yes, ma'am.
What's its formula then?
PBS.
PBS. There you go. Okay. Sodium is Na +1. Phosphorus is P -3. Okay? Crisscross,
Na3.
Na3, 1P. Ask questions. Anybody?
I really don't get how you're.
Just do the crisscross, sweetie.
Okay,
Is that
I
it?
don't know, but whenever I take notes, I honestly I just write them and don't really understand.
Okay, then you need to go back and read and study your notes until you do understand what we did. I also posted the video again. You can go watch it and rewatch it and not have to write, yes? But go ahead and ask your question. What part do you not understand?
I mean, I get where you're getting plus and -3, but then the whole.
Crisscross is formula writing. What did I tell you it was yesterday? What did the sum of the charges have to equal? What did the sum of the charges have to equal yesterday? 0. This is the crisscross makes the charges on the compound go to 0. So, honey, all you have to do is draw your arrow. Na gets 3, P gets a 1. Don't make it harder than it is. We just showed you something very similar to that right here. It took 3 chlorines to neutralize the Al, to take all 3 valence electrons. This is the opposite. It takes 3 sodiums to neutralize and give phosphorus. When they bond, it has to give phosphorus 3 electrons. There's the 3, there's the 1. Come in for tutorials. Okay? Zinc. Now, zinc is a transition metal, but if you look, it doesn't have a Roman numeral. Go to number 30. Do you see zinc on my periodic table? What do I have written in black above zinc? +2, because it doesn't change. Zn +2. Here we have phosphorus again, which is a what? Crisscross. Tells you how to write the formula. So Zn how many? P how many?
2.
Okay. Chromium is a transition metal. Cr +2. Sulfur is in what group? So it's S minus what? S minus 2. Oh, is it a 1-to-1? So what's the formula? CRS. Can you see this is going to be another 1-to-1? PB is a what? +2. O is a what? -2. What's the formula? PBO. Okay, I think I have you rolling well enough.
We do number 6 actually.
Number 6.
It's using a metalloid.
Okay, well, that one, yeah. Calcium's what?
+2.
Okay, go find AS. It's like nitrogen and phosphorus. It's arsenic, As minus 3. Crisscross, Ca gets the 3, As gets the what?
2.
Okay, so Ca3, As 2.
Wait, shouldn't it be a subscript, not a?
Oh yeah, my bad. Thank you. I'm going to do 7 with you. It's the first time we've seen hydrogen function as a cation. Hydrogen is a +1 because it lives where? Group 1. Okay, Telluride. Is that number 52 on your periodic table? Okay, so that's Te, and it's in group what? Just like oxygen? -2. So crisscross, who gets the 2? H2, Te. Okay? Do what?
Does it matter where I put the number? Does it have to go at the bottom?
It does, absolutely. The arrows point where it goes. And if you go back and look at your notes yesterday, it was always written at the bottom. Don't do what I did just a minute ago. Okay, let's do some names. What's the name of H? Yes. Name of this one. What's the name of Li? Lithium, Br is bromine. Bromide. Na?
Sodium. Chloride.
Mm-hmm. Ki? Who's K? Who's CS? Mm-hmm. Mm-hmm. I want to go find one that has, let's do it, number 10 over here. Oh, yeah. Manganese is transition metal. Now, this you're going to have to be on your toes. I don't know manganese, but I know oxygen. What was oxygen? No. What was it? Oxygen's ionic charge. Remember, the sum of the charges have to go to what? 0. Oxygen is a -2. What does that make manganese have to be? A +2. And you can also tell that it was a 1-to-1 ratio, wasn't it? Okay. So this is manganese. What do you have to have if you're a Roman numeral? What is my pen pointing to? Roman numeral 2. Oxide. Okay, now this one I'm going to educate you on. Everybody look up at my screen. Okay. Don't know what mercury is?
Hg. 80.
Right. This is mercury. Okay, look what I'm going to do here. I'm going to undo the crisscross. What did that just tell me about mercury? +2 charge. No,
No.
they're metals. Metals are never negative. Okay, so my 2 came from mercury in the crisscross, didn't it?
Yes.
Okay, so my name is mercury.
2.
That's right.
Chloride.
2 chloride.
Wait, how come on some of them you have to put the road numeral on some of them you don't?
Because bags got all that stuff.
If you go back to your notes yesterday, transition metals have to carry a Roman numeral in their name.
Because transition metals, is it because they can be
Multivalence.
multivalent?
See, you'll never know the charge of your transition metals. I never made you write charges up above any of the transition metals, did I? The only ones that do not change are zinc, silver, and cadmium. And if you look up there on mine, you'll see a written charge up above their symbol. Everybody else is multivalent. Okay, what I want you to do is I want you to finish off the formula writing in the first group here and the naming in this group right here.
Oh, you just name on the back?
Yeah, just naming on the back. So the whole left side,
Oh, the whole left side.
the whole left side is your assignment.
You want to do the rest of the bottom?
Well, you don't have to mess with this. I just needed to show you, if you run across it on the left side on the back, I needed to show you how to deal with it. Does that make sense? So just do what's over here on the back. Let's go to number 12. I want to show you, well, I want to do it again. Cobalt is a transition metal. I don't know its charge, but I know where the 2 came from, so I undo the crisscross. What was cobalt? Plus 2. So its name is cobalt 2 chloride.
Would that be the same for 13? Do that?
Yes, ma'am. Okay?
Come,